The next question we ask is, well, let's say the B range goes from 75 to 90. How many B's do we expect? Okay, for a score of 75, what's Z? It's, well, first of all, how far are you from the mean? How many standard deviations are you from the mean at 75? The mean is 85. So you're 10 units below the mean. So that your Z-score is going to be negative 10 divided by the standard deviation 3.4, or negative 2.9. You're at negative 2.9 standard deviations. So picture on a normal curve would be we go up to 1.5 and we go down to negative 2.9. Now the question becomes, how much of the area under the curve lies between here and here, and how much of the area lies between here and here? Well, we found out before by looking at the table that if Z equals 1.5, you have 0.433, 43.3% of your distribution. What about a negative number? Well, the distribution is completely symmetric about the middle. So if we wanted to look at Z equals 2.9, which would be the area between 0 and 2.9, that would be identical to the area between 0 and negative 2.9. So looking at 2.9 on the table, we don't worry about a plus or minus. We just look it up and we see that it's about 49%, 0.49 of the total area. Now when we draw the picture, we certainly want to take the negative and the positive into consideration. Between negative 2.9 and plus 1.5 is very different than between 1.5 and plus 2.9, for example. The information that we've got then says that 49% or 0.49 of the population lies between negative 2.9 and 0, and 0.433 or 43.3% lie between 0 and 1.5. Well, the total area between here and here will be the sum of the 0.49 and the 0.433. We add those, we get 0.923 or 92.3% of our population is going to score at least a 75 if we have a normal distribution. Now we'll talk in a minute about how this really isn't a good interpretation of that data, or might not be a good interpretation of that data, depending on how the data runs. Then our 92.3% of the 200 people, if we want to find the actual number, we take this proportion of the 200 people and we see that 184 people would be expected to make B's if this is a good normal distribution. Now, if we back up a minute, we've seen how distributions can be skewed. This distribution might peak here and then tail off very gradually out here, whereas the central tendency would be over here. There'd still be a lot of scores up here. And if the distribution isn't really a good normal distribution, then this interpretation is only going to be an approximation, and maybe not even a very good one, if we deviate significantly from the symmetry of the normal distribution. And that depends on the situation. In some situations you do expect a nice normal distribution. In others you expect a skewed distribution.